So now you can see that we've created our load patterns. So let's go back to load case before we come back here. Let me show you something in load cases. Okay. So now you see we've created those load patterns automatically. They are here in load cases. What we can do is now see, for example, my dead is a linear static type. I can modify it and change it to whichever one I want. So I can come here, change it to non-linear static, this, modals, response spectrum, time history, buckling, hyperstatic. I can change it. Now you can see my scale factor is 1. So let's say, for example, I don't want to create a load combination. I can just come here and I know my Euro code and my scale factor is 1.3, sorry, 1.35. I can just leave it as 1.35 here. So but I won't do that because I still want to create some combinations. So I can come here, change it to 1. Then I can also change this one too and change it to live. Okay, I look for live and add it and put the scale factor, so I can create my combinations and choose them here. But I'm not doing that, so I'll delete it and click OK. So this is also modal. Also you can come here. Modal is to show you the displacement, the mode displacement. So it depends on the number of stories you have. If you have a very tall story, like ours is 16-story building, and each node has about 6 degrees of freedom. So what they have is rotation in the X, Y, and Z direction, and they have translation in the X, Y, and Z direction. So I can put it here as 16. Okay, 16 times 6. Okay, so that's what we have. So it will have 96 number of modes. But the problem is because it's going to take a lot of time. So let me leave it as 12. It doesn't matter. We'll get to the part where we'll check if the nodal mass participation ratio is close to it. If not, we'll have to come back here to increase it. And you can change it from eigen to Ritz, whichever one you want, but I would advise you to leave it as eigenvector. So for mass add this and click OK. Now we are done with this. Now for example, your wind, you can also change it to non-linear static. You can change it whichever one you want. You can, but this hyperstatic is for post tension. You can do buckling, you can do whichever load case type you want to design it as. So you choose it, but I'll leave it as linear static and click OK. So we are done with that. Now let's go back to our define and let's go back to patterns. Okay, now you can see my WX, there is no lateral this. So what I want to do is come here and choose, I'm using Eurocode, so I'll choose Eurocode 1 part 4, that's for wind. Okay, select it and you see it, modify load. So once you select modify load, this one will be on. Same thing with this, to choose Euro and modify load. With this I'll choose Eurocode 8. Okay, so Eurocode 8 and modify load. Then this also Eurocode 8 and modify the load. So let's talk about the lateral system now. So we have the WX, so we just select modify lateral system, select it. Now we have our wind, and Eurocode generally has said we should use a 10 minutes wind speed. So for example, in a place like Lagos, our 3-second gust is 33 meters per second, but to convert it to 10 minutes wind speed, what you have to do is you multiply it times a factor. So we have 33 times 0.7, or if you don't know this factor, you can use your dust curve to convert it to 10 minutes wind speed. But for British code, British tells you to use 1 hour mean speed, so you multiply it times 0.6, whichever one you are using. So this is what I'm using, so I'll select it. So this is my 10 minutes wind speed. And my terrain category, I know is in Lagos, and Lagos is a city, so I'll use this one, high rise. Okay, so now I want to do my exposure height. So it's starting from a roof and the bottom story, because I know the ground floor is inside the ground, wind won't get to it, so I'll stop it at the first floor. Okay, now if there's a parapet wall on the roof, maybe the height of our parapet is 1 meter, so it will be on the roof, it will include it, but there is no parapet, I will ignore it. Okay, now we have our wind direction. So let me open this to explain it to you. Sorry, okay, um okay, So let me explain this to you. That is Euro Code 1 part 4. So let's look at what we have. So this is for wind, and it's similar to that of the British standard. Okay, so let's go. So let's look at what we have here. So get there. Yes, so let's look at what we have here now. So if you follow this, if our wind is coming in this direction, so the wind is coming in this direction. Let me open paint, sorry, to sketch some things. Okay. So now let me stretch it so I can utilize your screen. So our wind, this is the building, right? This is the building. Now let me erase it so there won't be any. So this is our building. Let me change the color of the wind now. So the wind is coming from this direction, right? So this is the windward direction and this is the leeward direction. So invariably the wind comes like this and blows like this. Okay. Also the wind comes like this and blows like this, creating a suction at this point. Okay. So now what it means is we have a coefficient. So CPE, so external coefficient. When you see E is external, and when you see CPI is internal coefficient. So now the wind is coming like this, so it is pushing it. You can see it, it is pushing this. It is pushing the windward direction. Then when it comes to this place, this is pulling it apart like this and is pulling it apart like this. So this one cancels this one, so it is 0. This one balances this one. I hope you understand. Now in this place it is pull. So if this is push, this is pull. But now you will see that when we get a CPE value of this, we'll be getting a value of negative. So we don't need to bother ourselves. What it means is like pushing the total force. So if, for example, the total pressure acting on this surface is 1 kilonewton per meter square. So and our coefficient of this place is 0.8 and the coefficient of this place is 0.2. So that means it means the whole 1 kilonewton is pushing in one direction. You can decide to, like it has now, you can decide to place for the windward and leeward. You still get the same thing. Don't look at the negative. Don't look at the negative. Negative is just telling you that it is pulling. So this is what we have. So if you have any question, you can always drop it and I will answer you. So let's go back to our code. Now let's look at our table. So we have CPE10 and CPE1, and it has said it in our graph here. We have a graph, logarithmical scale. It's telling you when to use it. So it's telling you when the area is greater than 1 square meter, you use CPE1, and sorry, when it's 1 square meter and below, you use CPE1. Then when it's greater than 10 meters square, and you use CPE10. So most of our structures are always within this CPE10. So it's in a logarithmical graph. So that's what we have. So now we need to know this ratio. Just look at this table, follow it. We need to know our ratio. So for example now, the h over d. So what's your h? So we can see our h is the height of the structure. So our height is about 49 meters. So 49 meters divided by d, small d, that is the sideways plan, this plan here, this plan. So our height there is, let me measure it from ETABS. Okay, so sorry, click OK. I'll come back to it to edit it. So let me explain what it is. Let's pick this floor. Okay, so now we are assuming our wind is coming from this direction, that is the x direction. So from here to here is 13 meters, right? So our height is h, which is 49 meters. So 49 divided by 13, so which is 3.7. So sorry, yes, 49 divided by 13 is 3.7. So we know where our member fall. Okay, so we can decide to interpolate if it's between here, but most times we won't bother ourselves interpolating. So what we need to do now is, we know the wind is coming here like this. This is our d direction. So look at the CPE10 of d, which is positive 8, right? CP of E positive 8. Now when the wind comes to this point, I said this point and this point will cancel out each other. There will be a section here, so that means what our value for E when we use something here. So our value for E will be, we can use the average value of 0.6 if we interpolate, so we can use the 0.6 value. So let's go back to ETABS, define, go to load patterns, yes, then we'll come back here. Now we'll choose modify lateral load and let's change this to 0.7. Okay, so this is the leeward. You don't need to put negative because it knows it is leeward, like I said, but if it doesn't know, you can do it. Now another thing you can do is you might decide not to use this method and just go there and use nodal load like I've been doing on Start Pro. So that means whatever your wind pressure is, you just add these two together. So this is 1.5, the total something is 1.5, so that means you can just put it at this side and 1.5 of it, because the displacement from here will be the same displacement at D when it's going in this direction. So you can set all other parameters you want. So we have 0.8, 0.7. Now the thing we need to do is come to this here and change it to 0. So the reason why I say you should change it to 0 is because that is the X direction. If you leave it as X and Y, the problem is our exposure, that is leeward and windward, could be different. So we have that issue. Now you can see your diaphragm. It has created the diaphragm from your X coordinate, everything. So but since I've changed it to 0 now, no problem. So I'll just click OK and click this. Next thing I'll do is I'll come to Y, modify lateral load. Okay, modify lateral load and change this to 90. So 90. Now I'll just click OK. So I'll change this to 33 asterisk 0.7. 33 asterisk 0.7, and this is Lagos, this is first floor. Okay, so now we need to work on our CPE and CP leeward and windward. So let's go back to our graph now. Let's get our height. Okay, our height is 49 meters. 49 meters. Then our, since the wind is coming like this, so this is the side. So our D is what? Our D is 8 meters plus 8 meters plus 6 meters. Okay, that is 22 meters. So divided by 22. So our CP is around 2.2. So we can still use the value of 1. It's closer to 1. So we'll come back to ETABS and leave it as this, because you can see your around 1 here. So 0.72. You can see it. Okay. So let's move on. I don't need to tamper with this. I don't need to tamper with this. Now we have the option of exposure from shell. So for example, if you put cladding, you can now do it will now be like pressure acting on the cladding member. Okay, but it's best to use the diaphragm. Okay, so click OK. Now we are done with the wind X and wind Y. Let's create the earthquake and X and Y direction, which we'll be doing in the next video. Thank you for watching today's video. If you have any question, you can drop it in the comment section. Thank you very much.